This is the Unit 2, or Unit 12 of the second semester final review. We've reached the final chapter. So in 36, we're given our function f of x equals x plus 2 squared minus 3. Now this is in the vertex form, which is really nice to pull the vertex from. We change our value on the inside and make that a negative 2. Bring the negative 3 down, keep it the same, and that is the vertex for this. So I go to negative 2, negative 3. It's as easy as that in vertex form. When it's in this form, you change the x value, keep the y value the same, you got your vertex. You blink, you might miss it. Now this one, since I have no negative right here, I know that it opens up, so that's taken care of. My domain of f of x, my domain of any of these parabolas is all real numbers, so we'll write all reals. My range, though, depends on where the y value is. So from the vertex, I get this negative 3. So my y values are in relation to this negative 3. They're all either all above it or all below it. Now the fact I know the parabola opens up, it's going to go in this direction. That means my y values are all greater than or equal to negative 3. Now, we got that from the y value of the vertex. The next one, the line of symmetry, is the x value in the vertex, which is negative 2. So if we draw this through here, that is your axis of symmetry. Now we said it did open up, so that means our vertex is a minimum. So now we can go through and graph this. Let's pick some points to plot. If I did, this is x and f of x. Let's try x is 0. If x is 0, I have 2 squared, which is 4, minus 3 is 1. So I know it hits there. If x is negative 1, negative 1 and 2 is 1. 1 squared is 1. And then minus 3 is negative 2, which would be right here. Now, that gives me a start of the parabola. And what I can use to help me out, because it is a parabola and it's symmetric, if I go 1 unit on the other side, 2 units away on the other side, I then have our sketch to work with. Now, on the same graph, they want us to graph g of x. Let me get a different pen. So g of x has a vertex at 4, 2, because we changed the sign, keep it the same. Its maximum, because it is going down, is the y value of 2. Its domain is all reals again. Since your range, we have a value of 2, and it goes down, it's going to be less than or equal to 2. Our line of symmetry is the x value, so that is when x equals 4. We should probably sketch this graph. We said the vertex is at 4, 2. It's going down. Let's pick some points here. So this is x and g of x. I'm going to plug in, let's go with like a 3. Because this, if we plug in 3, we get 3 minus 4 is 1, 1 squared. And then times negative 2, this comes out to be 0. So it hits at 3, 0. If it hits there, it also hits on the other side of our axis of symmetry. Let's go to 2, plug 2 in. X minus 2 is negative 2, squared is 4, which is negative 8, plus 2 is negative 6. So then we're going down 6 to here. And there's our graph of g of x. This is okay. If we want to check if negative 6 is a solution, all that means is we're going to plug it into our equation and see if that works. So let's go negative 6 would be our y value, or g of x. Negative 2, then we'll do 6 minus 4 squared plus 2. So all of this has to come out to be negative 6. Well, 6 minus 4 is 2. 2 squared is 4. 4 times negative 2 is negative 8 plus 2. And it looks like that comes out to be negative 6, so it matches, so we'll say yes. And then it wants to know 2 other solutions that we have. Now we kind of did this work already over here. We know that 3, 0, and then 2, negative 6 would work. But really you could pick any x values to plug in. That'd be your x value, and then your y value would be the result that you get. Now the descriptive form of this parabola in this form is best to determine the vertex, which we kind of already mentioned. It's also good, we could maybe say like the min and max is good. The direction, the range, I'm not really sure how much more they want, but really that vertex is the big one we get from it that's quite nice. If we go down to 37, we have the equation x squared minus 2x minus 8. We need to find the vertex. To do that, we actually find the line of symmetry first, which is x equals negative b over 2a. And that's going to be negative negative 2 over 2 times 1, which is 2 over 2. It comes out to be 1, which is our x value. We then plug that back into our equation. And so it's 1 squared minus 2 minus 8. Looks like it's going to be a negative 9. Now, explain how you get the line of symmetry. We kind of mentioned that x equals negative b over 2a is what you're going to use. They want us to now graph this. And let's get some easy stuff out of the way. We know the y-intercept is negative 8 because we make the x is 0 and we get there. So 0, negative 8, we have. 1 goes to negative 9. We got that as well. Jumping down here to factor, this will help us a little bit. Multiplying to negative 8 adds to negative 2. I could do x minus 4, x plus 2. What's nice about that is then I know I have two solutions at 4 and negative 2, which are actually our x-intercepts. So up here on our table, whenever it's 4, we get 0. When it's negative 2, we get 0. And also cheating a little bit, since this is our vertex, we know it's symmetric on either side. So if I plugged a 2 in, I would also get negative 8. Now I can plug a negative 1 in up here, and I would get 1 plus 2 minus 8, which would be negative 5, which is either side of those. We keep going. This one, plugging in, would be a 7, and then I believe we'd have 32 for those. Now, we can plot these. We got 4, 0, 3, negative 5, 2, negative 8. We're kind of off the grid here. And we can see this is where the parabola fits. Okay, what is the relationship between the factors and the x-intercepts? If you notice, when you get your factors equal to 0, using the zero product property, it gets you to say x minus 4 equals 0, x plus 2 equals 0, which gives you your solutions or your factors that you have. So you set the factors equal to 0, and that gives you your solutions. It's probably the better way to write it there. Now, the standard form of the parabola is the best way to reveal the value of the, I would say, the y-intercept without changing anything, because again, we can just make the x is 0. It automatically gives us the y-intercept. Now, f, on the other hand, when it's in that factored form already, this is definitely the best way to find the x-intercept, or like it calls it, the zeros or the solutions of the equation. Okay, on 38, we're going to graph x squared, which looks like this. Okay, and then we need to sketch the translation that if we went plus x plus 3, y minus 2. Now, if I add 3 to x, it means I move 3 to the right, and 2 to y means I move down 2. So I'm going to take and move everything over 3, down 2, so my vertex is here. Now, it still follows the same pattern. It goes up 1, or over 1, up 1, over 2, up 4. It still has the same shape, but it was shifted. So if we wrote that out, this would be f of x, I guess I want t of x. T of x equals, I would go a x minus 3 squared plus or minus 2. Okay, that is the vertex form that we had earlier. Remember, we changed the sign, make it a negative 3, and then squared minus 2. Now r of x, which was right here, is decreasing when x is less than 0, because it's going down right here. Anytime to the left side of the vertex, it's going down. And that means it is increasing when it is bigger. So that's going to be going up. Could this be the last page? 39, rate of change, h of x, x squared. Here's what I'm going to do here. I'm going to start with writing x and h of x. My values, if x is 1, I got 1. 2, I got 4. They also want 5, which is 25, and 8, which is 64. So if I want to see the rate of change between 2 points, 2 to 5, I'm really looking at the slope, but when it's 2, 4, and 5, 25, because the x values give me the points. So it comes down to being the slope, and slope, which you hopefully know, is change in y over change in x. So I went from 4 to 25. My slope went up 21 for my y values. I went from 2 to 5, it went up 3, so my slope is in fact 7. Now when we go from 5 to 8, 5 being 5, 25, and 8 being 8, 64, my change in y, 64 minus 25 is 39. Change in x is 3, that reduces to be 13. So the average rate of change is different than the graph, because in a parabola, the slope is not constant. It is changing, it is actually getting steeper the further it gets from the vertex, which you could put right there. As long as you understand that, it's different than a line, the slope is changing in steepness as it goes. So now we shift gears in 40 and we're solving the equations. We're looking for solutions. These could also relate back to the graph because these are also the x-intercepts. If I can't factor nicely, I'm going to eventually use quadratic formula. But this one starts out nice. I can make it 2x squared equals 18 by adding 18 to both sides. I get x squared equals 9. When I take the square root of both sides, it gives me 3 and negative 3, because it has two solutions, because both 3 and negative 3 squared come out to be 9. For b, I get 75x squared equals negative 48. If I divide that, I get negative 48 over 75, which I'm not even going to simplify, and I'm going to stop right there, because I'm going to eventually, if that works out, take the square root of both sides, and taking the square root of a negative gives me no solution. I should say no real solution in this case. Now for c, I'm just thinking factoring, back what we did in unit 11. I'm going to multiply to negative 21 and add to negative 4. So what I could do here is say x minus 7, x plus 3 equals 0. And factoring it nicely, I can then say x equals 7, x minus 7 equals 0, so x equals 7, and x plus 3 equals 0, so x equals negative 3. So my two solutions are 7 and negative 3. For d, I notice I have a common factor. I'm going to take out a 2. And actually, when that 2 is factored out, it's not a solution, so it's actually just going to be gone, and I'm left with x squared plus 9x plus 20. Multiply to 20 adds to 9. Looks like 5 and 4 are our winners. So those are our factors, not our solutions. We then set x plus 5 equal to 0, and that gives us negative 5. And x plus 4 equals 0 gives us negative 4. And we have our two solutions. Now we look at e. E, I need to figure out multiply to 36, add to negative 15. So if I'm not real sure where to go, I could use quadratic formula. I'm going to go with factoring on this one, and then we'll do quadratic formulas on the rest. Because this one's nice. If I did negative 12 and negative 3, I can break it up. So now it's going to be factored by grouping. Take out a 2x, x minus 6. Take out a negative 3, x minus 6. So x minus 6 is in both of them. Leftovers is 2x minus 3. But I'm not looking for factors, I'm looking for solutions. So I say x minus 6 equals 0. That means x equals 6. 2x minus 3 equals 0. I get 2x equals 3, or x equals 3 over 2. Solutions are 3 over 2 and 6. Now for f, the first thing I have to be careful with is make sure everything is on the same side. I got 3x squared plus 17x plus 10 equals 0. I'm going to go quadratic formula for this one. And quadratic formula, which we should remember, grab a piece of paper, we need some more space here. So quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So for this problem, a is 3, b is 17, and c is 10. So when we solve, we're going to go negative 17 plus or minus 17 squared, which is 289, minus 4 times 3 times 10, and all of that is over 2a, which is 2 times 3, or 6. So inside my square root, got 289, obviously, and then I'm going to do 4 times 3 times 10, which is 120. This gives me x equals negative 17 plus or minus the square root of 169 over 6, which is nice because that's a perfect square. Negative 17 plus or minus 13 over 6. Now at this point I'm going to split into two types. I have negative 17 plus 13 over 6 and negative 17 minus 13 over 6. Together, negative 17 and 13 is negative 4, which means I'm going to have x equals negative 2/3. And then on the other side I get negative 30 over 6, which comes out to be negative 15 over 2. No. 5 by 5. Negative 5. So I get x equals negative 2/3 and negative 5. For our next one, we're on G now. Let's write these answers in. X equals negative 2/3 and negative 5. Okay, I'm going to go quadratic formula, and that's going to be a is 2, b is 5, c is 1. We're going to go negative 5 plus or minus the square root of 25, 5 squared, minus 4 times 2 times 1. All of that is over 2 times 2, or 4. So negative 5 plus or minus the square root of 25 minus 8 over 4. X equals negative 5 plus or minus the square root of 17 over 4, which we see is not going to simplify. So we could actually leave it as this, or negative 5 plus root 17 over 4, comma, negative 5 minus root 17 over 4 as our solutions. So we'll write these in. Okay, now for H, x equals, we're going to go negative 2 plus or minus the square root of 4 minus 4 times 3 times negative 4 over 6, because that is 2 times 3. Negative 2 plus or minus, we got 4 plus, that looks like 12 times 4, or 48. So we get x equals negative 2 plus or minus the square root of 52 over 6. Now I'm going to look at 52 off to the side. 52 divided by 4 is 13. So I could simplify this one into 2 root 13, because I can take out a 2 squared or a 4. So this becomes negative 2 plus or minus 2 root 13 over 6. Now, in factoring these, since all three of these have a common factor, I'm going to divide out at 2, and it's negative 1 plus or minus root 13 over 6, which we could leave as that, or write negative 1 plus root 13 over 6, and negative 1 minus root 13 over 6. Okay, on to 41. so we have our equation, negative 1/2 x plus 4 squared plus 2, and then that's k of x, and m of x is here. So we got to look true and false. Now, I don't need to graph these. I can actually get some good information from this. If I look at m of x, I notice that it goes down, 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 then it starts going up, 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 up. So that means this is the vertex. It also means if that's the bottom, it's a minimum, and it has a range when y is greater than or equal to negative 4. So let's see if that's enough to help us out. Okay, now over at k of x, we have that our vertex is negative 4, 2. Negative 4, 2 is here. So this is k of x's vertex, and it goes down. And let's go 3, negative 4 is the vertex, and this is m of x. All right, so the maximum value of k of x is greater than the minimum value of m of x. The maximum of k is up here at 2. The minimum of m of x is down here at negative 4. So the maximum of k of x is bigger. That's true. We'll say 2 is bigger than negative 4. Okay, the value of x when k of x is at its maximum, so that is negative 4, is greater than the value of x when x is at its minimum. When m of x is at its minimum, which is over here at 3. So that's saying is negative 4 bigger than 3? False. Negative 4 is not bigger than negative 3. Okay, both x-intercepts of m of x are greater than 0. So m of x is over here. Where does it hit the x-axis? Well, it hits the x-axis when m of x is 0. Right here, right here. So they are 1 and 5. Those are both greater than 0. We're going to say true. The line of symmetry for k of x is 4. That is false because the line of symmetry is when x is negative 4, as we're out here in the negatives. And the y-intercept of m of x is greater than the y-intercept of k of x. I don't even need to know what the y-intercept is, because here's why. M of x is going to go up, and it's going to hit, if we just kind of just trace it along, somewhere up there. K of x is going to kind of go like that. Well, m of x is going to hit higher up just by the shape that it follows. So in that case, we know it's greater because we can kind of sketch out the graph. What you could also do is I could plug in 0 for x in both graphs. And it looks like we get negative 6 is the intercept. It'd be nice if I was on the screen. Negative 6 is the intercept for k of x. And then m of x, at x equals 0, it's 5, and 5 is greater than negative 6, so that one is true.